Dr. Shantanu Ghosh from the behalf of Department of Chemistry, Kandra, Radha, Kundu, Mahavidyalaya. I am Dr. Krishna Gopal Thakur. So let me say a few words about Dr. Shantanu Ghosh. He completed his master degree in organic chemistry specialization from Vishwabharati University at the year of 2013. Then he went to IIT Guwahati and completed his PhD under Professor Jana. He awarded got the award at the year of 2021. Then he went to France and he is presently working at the Laboratory of Organic Chemistry and Photochemistry, which comes under University of Strasbourg, which is situated in France, northern France, nearing Germany. Very pleasant place. And now I would request our principal sir to say a few words about welcoming Dr. Shantanu Ghosh. Then he will give his talk regarding amides, which is very important part in organic chemistry. He will specially talk about the importance of amides and some synthetic routes available for amides. So please, sir, you say a few words about welcoming Dr. Shantanu Ghosh. Please carry on, sir.
শুভ সকাল প্রত্যেককে এই আষাঢ় মাসে ঘন ঘটার শুভ সকালে সকলকে আমাদের কলেজের তরফ থেকে অভিনন্দন এবং শুভেচ্ছা রয়েছে। আজকে আমরা মিলিত হয়েছি একটি ইন্টারন্যাশনাল ওয়েবিনারে, যেখানে কেমিস্ট্রির আলোচনা হবে এবং আমাদের খুব সৌভাগ্য যে এই আলোচনায় অংশ নিচ্ছেন ডক্টর শান্তনু ঘোষ, যিনি এই মুহূর্তে ফ্রান্সে রয়েছেন। ফ্রান্সের একটি ইউনিভার্সিটিতে তিনি পড়াশোনায় গবেষণায় তিনি রত রয়েছেন। একটু আগে আমাদের কৃষ্ণ গোপাল ঠাকুর তিনি তার সম্পর্কে বললেন। আইআইটি গুয়াহাটি থেকে তিনি পিএইচডি করেছেন এবং পোস্ট ডক্টর করার জন্য তিনি ফ্রান্সে গিয়েছেন। তাহলে এই ধরনের একজন কৃতি গবেষককে আজ আমরা পেয়েছি এবং আমি আশা রাখি এবং বিশ্বাস করি যে আজকে আমাদের কেমিস্ট্রি ডিপার্টমেন্ট তথা সায়েন্সের যারা রয়েছেন তারা তার দ্বারা উপকৃত হবেন, তার দ্বারা সমৃদ্ধ হবেন, এটা আমরা আশা করছি এবং বিশ্বাস করছি। এটা খুব সত্য কথা, আজকে সায়েন্স এবং টেকনোলজি যে জায়গায় পৌঁছে গিয়েছে সেটা কিন্তু চিন্তার বাইরে এবং আগামী দিনে এর আরো বিস্তার হবে, এতে কিন্তু কোনো সন্দেহ নেই। আজকে সারা বিশ্ব জুড়ে যে ভয়ঙ্কর মহামারী চলছে, একটা ছোট্ট ভাইরাস যা আমাদের সমগ্র মানব জাতিকে বিপন্ন করে তুলেছে এবং সেই মারণ ভাইরাসের হাত থেকে বাঁচার তাগিদে এক একটি দেশ, এক একটি রাষ্ট্র এক এক রকমের ব্যবস্থা অবলম্বন করছে। কেউ লকডাউনের পথে যাচ্ছে, কেউ লকডাউন খুলে দিচ্ছে, অর্থাৎ একটা বাঁচার একটা তাগিদ আমাদের প্রতিনিয়ত থেকে যাচ্ছে। পদ্ধতি, উপায় সে সম্পর্কে চিন্তা ভাবনা এক এক দেশে এক এক রকমের রয়েছে। আজকে ইউরো খেলা চলছে এবং সেখানে আমরা দেখছি যে বিদেশের মাঠেতে খেলা চলছে, সেখানকার মানুষেরা খেলা দেখছে, স্টেডিয়ামে আসছে, আর আমরা ভারতবর্ষের মানুষেরা, পশ্চিমবাংলার মানুষেরা লকডাউন হয়ে বসে রয়েছে। সুতরাং এই যে চিন্তা ভাবনার যে পার্থক্যটা, পরিবেশগত যে পার্থক্যটা, এটা কিন্তু থেকে যাচ্ছে। সে যাই হোক, আজকে মহামারী অন্তত পক্ষে এটা আমাদের শিখিয়েছে যে বিজ্ঞান ছাড়া, বিজ্ঞানের উন্নতি ছাড়া আমরা এক পা এগিয়ে যেতে পারবো না। এই মারণ ভাইরাসকে রক্ষা করতে গেলে কাব্য কবিতা দিয়ে হবে না, ইতিহাস চর্চা দিয়ে হবে না, অঙ্কন বিদ্যা দিয়ে হবে না। এই মারণ ভাইরাসকে মারতে গেলে বিজ্ঞান চাই। ফলে সারা পৃথিবীর বিজ্ঞানীরা এই মারণ ভাইরাসের বিরুদ্ধে লড়াই করে যাচ্ছে, ডাক্তারবাবুরা লড়াই করে যাচ্ছে। কিন্তু এই যে মহামারীর প্রকোপেতে আমাদের শিক্ষা ব্যবস্থা সব থেকে বড় অবহেলিত হয়ে গেছে। আজকে ছাত্রছাত্রীদের মধ্যে শিক্ষার একটা বিরাট একটা ফাঁক থেকে যাচ্ছে। ছাত্রছাত্রীরা আজকে পড়াশোনা থেকে বিমুখ হয়ে যাচ্ছে, কারণ তাদের মধ্যে পরীক্ষা নেই, তাদের মধ্যে কোনো প্রতিযোগিতা করার মানসিকতা নেই। আজকে বিজ্ঞানের মতো বিষয়গুলোতে বিনা ল্যাবরেটরিতে তারা পাস করে যাচ্ছে। অনলাইনের মাধ্যমে যদিও পড়াশোনা হচ্ছে, পড়াশোনা করার চেষ্টা করা হচ্ছে, কিন্তু আমার মাথায় ঠিক ঢোকে না যে কেমিস্ট্রির মতো সাবজেক্ট, ফিজিক্সের মতো সাবজেক্ট, জুলজি, বোটানির মতো সাবজেক্ট গুলো উইদাউট ল্যাবরেটরিতে কি করে পড়াশোনা হবে। এগুলো আমাদের মাথায় ঠিক মতো মানে ঢোকে না। তাহলে আমার মতে আজকে এই ভয়ঙ্কর মহামারীতে সব থেকে বেশি ক্ষতিগ্রস্ত হচ্ছে ছাত্রমহল, শিক্ষকেরাও ক্ষতিগ্রস্ত হচ্ছে। ছাত্রের ক্ষুধাকে মেটানো হচ্ছে শিক্ষকের কাজ এবং তার কর্তব্য, সেটা কিন্তু আমরা পাচ্ছি না। তবুও আজকে প্রযুক্তির মাধ্যমে, অনলাইনের মাধ্যমে চেষ্টা চলছে যাতে করে ছাত্রছাত্রীরা একটু পড়াশোনার দিকে আগ্রহী হয়। এই জন্য আমরা সিদ্ধান্ত নিয়েছিলাম আমাদের কলেজের তরফ থেকে, কলেজের কর্তৃপক্ষের তরফ থেকে এই সিদ্ধান্তটা আমাদের নেওয়া হয়েছে যে প্রত্যেকটি ডিপার্টমেন্টকে অনলাইনের মাধ্যমে, আধুনিক প্রযুক্তির মাধ্যমে ওয়েবিনারের ব্যবস্থা করতে হবে। ওয়েবিনারের ব্যবস্থা করলে কি হবে, যে চিন্তা ভাবনাগুলো আমাদের ছাত্রদের মধ্যে সেটা জারিত হয়ে যাবে, অন্তত কিছু তারা শুনবে। রেগুলার আমাদের মাস্টারমশাইদের কাছ থেকে যা শুনছে তার থেকে অন্য কিছু শোনার একটা বাসনা তাদের মধ্যে জাগবে। অর্থাৎ এই ওয়েবিনারের মাধ্যমেতে বিশ্ব কোথায় চলে গেছে, তাদের চিন্তা ভাবনা কোথায়, এটা তারা বুঝতে পারবে, তারা শিখতে পারবে, নিজেদেরকে তারা তৈরি করে নেওয়ার মতো মানসিকতা দেখাতে পারবে। আজকে শান্তনু ঘোষ এদের কাছে একটা রোল মডেল হতে পারে, যে একটা ছেলে বিজ্ঞান চর্চা করে আজকে সে বিদেশে রয়েছে। অর্থাৎ আমার কলেজের ছাত্ররাও যদি এই চেষ্টাটা রাখে, তাকে যদি সামনে রাখে যে শান্তনু যেটা পেরেছে আমি সেটা পারবো না কেন, এই যদি মানসিকতা তাদের মধ্যে দেখা দেয়, আমার মনে হয় তারা কিন্তু অনেকখানি এগিয়ে যেতে পারবে। এটাই হচ্ছে আমাদের ওয়েবিনারের মূল উদ্দেশ্য, যে কিভাবে আধুনিক গবেষণায় বিজ্ঞান এগিয়ে চলেছে, সেই ধারাটা আমার ছাত্রছাত্রীরা বুঝতে পারবে বলে আমি আশা করতে পারি। আমরা সকলেই জানি যে আমাদের কান্দ্রা রাধাকান্ত কুন্ডু মহাবিদ্যালয় খুব বেশি পুরনো দিনের কলেজ নয়, মাত্র 2001 সালে তার পথ চলা শুরু হয়েছে। প্রথম দিকেতে শুধু আর্টস পড়ানো হতো, পরবর্তীকালে আমরা বিজ্ঞান শাখা খুলেছি। বিজ্ঞানের প্রায় সকল শাখা, ফিজিক্স, কেমিস্ট্রি, ম্যাথামেটিক্স, জুলজি, বোটানি, আমরা চালু করতে পেরেছি, আমাদের আলাদা একটা বিজ্ঞান ভবন আমরা তৈরি করতে পেরেছি, এবং আধুনিক প্রযুক্তিসম্মত ল্যাবরেটরি করার আমরা চেষ্টা করেছি, অর্থাৎ আমাদের চেষ্টার কোনো ত্রুটি নেই। এবং আমি খুব গর্ববোধ করি যে আমরা এমন কিছু তরুণ শিক্ষককে পেয়েছি যে যারা অক্লান্ত পরিশ্রমের মাধ্যমেতে আমাদের বিজ্ঞান শাখাকে প্রতিষ্ঠিত করার জন্য তারা লড়ে যাচ্ছে। বিশেষ করে আমাদের কেমিস্ট্রি ডিপার্টমেন্টে কৃষ্ণ গোপাল রয়েছে। কৃষ্ণ গোপাল তো এমনি খুব কৃতি ছাত্র, সে বিভিন্ন আইআইটি থেকে সে পড়াশোনা করেছে, গবেষণা করেছে, এবং তার চিন্তা ভাবনা নিশ্চয়ই আমাদের ছাত্রছাত্রীদের উপকারে আসছে। এবং তার সঙ্গে সঙ্গে সুজিত ঘোষ রয়েছে কেমিস্ট্রি ডিপার্টমেন্টে, অত্যন্ত ভালো ছেলে, ভদ্র ছেলে, খুব চিন্তা ভাবনা করে, পড়াশোনা করার চেষ্টা করে, ছাত্রছাত্রীদেরকে বোঝাবার চেষ্টা করে, ছাত্রছাত্রীদের সঙ্গে তাদের একটা খুব ঘনিষ্ঠ একটা সম্পর্ক রয়েছে। এটা কিন্তু আমাদের কাছে খুব একটা গর্বের বিষয়। কেমিস্ট্রি ডিপার্টমেন্ট আগামী দিনে আশা করব আরো ভালো হবে। শান্তনুর মতো ব্যক্তিত্বরা এদিকে যদি একটু গাইড করে, এদিকে যদি একটু সাহায্য করে, মাঝে মাঝে যদি এইভাবে বক্তৃতার মাধ্যমে যদি চেষ্টা করে, তাহলে পরে আমার মনে হয় আমাদের কেমিস্ট্রি ডিপার্টমেন্ট অনেকখানি উন্নতি লাভ করতে পারবে। আমি আর বিশেষ কিছু বলবো না। আমি শান্তনুকে আরেকবার অভিনন্দন জানাচ্ছি যে তার অমূল্য সময় নষ্ট করে সকালবেলাতে, এখন ফ্রান্সে এখন 7টা বাজছে, সে এসেছে, আমাদের ডাকে সাড়া দিয়েছে, আমাদের ছাত্রছাত্রীদের জন্য কিছু বলবে। এটা আমাদের কাছে একটা খুব বড় পাওনা। কারণ আমরা সকলেই জানি যে সে যে দেশে রয়েছে সেই দেশটা হচ্ছে ফ্রান্স। একদম অতীত থেকে আজ পর্যন্ত ফ্রান্স ইউরোপের ইতিহাসে একটা গুরুত্বপূর্ণ অধ্যায় সৃষ্টি করতে পেরেছে। আমরা যে আজকে গণতন্ত্রের কথা বলি, আজকে যে আমরা বিশ্ব ভ্রাতৃত্বের কথা বলি, তার প্রভাব প্রথম শুরু হয়েছিল ফ্রান্সে। আমরা যারা ইতিহাস নিয়ে পড়াশোনা করেছি আমরা জানি যে 1789 সালেতে ফ্রান্স গোটা পৃথিবীকে পথ দেখিয়েছিল। ফরাসি বিপ্লবের মাধ্যমেতে রাজতন্ত্রের অবসান ঘটিয়ে সেখানে প্রজাতান্ত্রিক শাসন ব্যবস্থা, জনগণের সরকারের প্রতিষ্ঠা তারা করতে পেরেছে। অর্থাৎ ফ্রান্স এমন একটা রাষ্ট্র যে রাষ্ট্রের দিকে মানুষ তাকিয়ে থাকে, এত ভালো ওখানকার কালচার, ওখানকার সৌন্দর্যবোধ, ওখানকার মানুষের যে মানসিকতা, সেটা খুবই গর্বের কথা। এটা আমরা সকলেই আমরা জানি। এদেশেই জন্মগ্রহণ করেছেন নেপোলিয়নের মতো শাসক, যিনি জন্মগ্রহণ করেছিলেন একটা সাধারণ জেলে পরিবারে। একটা জেলে পরিবারে সন্তান হয়েও তিনি ফরাসি দেশের সম্রাট হতে পেরেছিলেন, ফরাসি দেশের সর্বোচ্চ শাসক হতে পেরেছিলেন, এবং গোটা ইউরোপকে তিনি করায়ত্ত করতে পেরেছিলেন। এগুলো কিন্তু আমাদের ভুললে চলবে না যে ফরাসির দেশ আমাদের পথ দেখিয়েছে। 1830 খ্রিস্টাব্দে জুলাই বিপ্লব হয়েছে, 1848 খ্রিস্টাব্দে সেখানে বিপ্লব হয়েছে। তৃতীয় নেপোলিয়নের মতো শাসক তিনি শাসন করে গিয়েছেন। এবং সব থেকে যেটা বড় কথা, যে ফ্রান্স একটা পুঁজিবাদী রাষ্ট্র হওয়া সত্ত্বেও নান্দনিক কৌশলকে তারা কিন্তু কখনো ভোলেনি। আজকে পৃথিবীর সব থেকে বড় জাদুঘর প্যারিসে রয়েছে। এগুলো খুব গর্বের বিষয়। এবং সেই দেশে তিনি পড়াশোনা করতে গিয়েছে, এটা আমার কাছে খুব ভালো লাগছে। কারণ ইউরোপ এমন একটা জায়গা, ফ্রান্স এমন একটা জায়গা যেখানে জাতি গৌরব করতে ভালোবাসে। ফরাসিরা গৌরববাহী জাতি, গৌরবলোভী জাতি। তাদের কাছে গৌরব ছাড়া অন্য কিছু থাকে না। তারা নান্দনিক, তারা শিল্পকলাকে বোঝে, তারা সব কিছুকে বোঝে। সেই জায়গাতে সে পড়াশোনা করতে গিয়েছে। এবং ফ্রান্স ইংল্যান্ডের সঙ্গে যে যুদ্ধ হয়, ইংল্যান্ডের সঙ্গে তাদের যে বিরোধ ছিল, সেই বিরোধের পরিণতিতে হয়তো ফ্রান্স অনেকটা পিছিয়ে পড়েছিল, কিন্তু দ্বিতীয় বিশ্বযুদ্ধের পর আগে থেকেই ফ্রান্স এবং ইংল্যান্ডের মধ্যে একটা দারুণ সম্পর্ক গড়ে উঠেছিল এবং মিত্র শক্তি তারা তৈরি করতে পেরেছিল। আমি আর বিশেষ কিছু বলতে চাইছি না। আমি শান্তনু জীবনের আরো উন্নতি লাভ কামনা করছি। সে আরো ভালো থাকুক, সুস্থ থাকুক, এবং ছাত্র সমাজকে, বিজ্ঞানকে সে আরো বেশি দিক, এটুকু বলছি। আসুন আমরা সকলে মিলে আমাদের আজকের আলোচনা সবাই অংশ নিই। আজকের এই আলোচনা সবাই যে সমস্ত ছাত্রছাত্রীরা অংশ নিয়েছে তাদেরকে আমি শুভেচ্ছা জানাচ্ছি। আমার যে সমস্ত সহকর্মীরা আজকে অংশ নিয়েছেন তাদেরকে আমি অভিনন্দন জানাচ্ছি। এবং সর্বোপরি যাদের জন্য এই এই আলোচনা সভা হচ্ছে, সেই কেমিস্ট্রি ডিপার্টমেন্টের 2 অধ্যাপককে আমি অনেক অভিনন্দন এবং শুভেচ্ছা জ্ঞাপন করছি। এবং টেকনিক্যাল যে সমস্ত মানুষেরা রয়েছেন, সুমিত কর থেকে শুরু করে পণ্ডিত, তারপর ইন্দ্রনীল ভট্টাচার্য, শাহবাজ, শফিকুল, এদের যে একটা টিম রয়েছে, যে টিম মানে ইউটিউবের মাধ্যমে এটাকে ছড়িয়ে দেবে, তাদের সকলকে আমি অভিনন্দন জানাচ্ছি। এবং আমি আজকের এই আলোচনা সভা শুরু করার জন্য ডক্টর শান্তনু ঘোষকে আহ্বান করছি। আমরা বিজ্ঞানের সাধক না হলেও বিজ্ঞানের অন্তত অনুরাগী, এটুকু বলতে পারি। নমস্কার। এই অতিমারির সময়তে সবাই ভালো থাকুন, সুস্থ থাকুন বলে এখানে আমি শেষ করছি।
Thank you very much, sir, for your warm welcoming speech. Now I request Dr. Shantanu Ghosh to start his talk about amides. Please, Dr. Ghosh.
Yes, sir. Thank you very much, Dr. Mrinal Kanti Chattopadhyay sir and Dr. Krishna Gopal Thakur sir for their nice meeting. So now I am going to present some thoughts that based on amide synthesis. So now I'm going to share my screen.
শাহবাজ দা স্ক্রিন শেয়ারটা দেখে নাও একটু।
হ্যাঁ স্যার, আপনি করবেন? স্যার আপনার পিপিটি চলছে, ঠিক আছে, আপনি ডাইরেক্ট পিপিটি তে চলে যান এবার।
দেখতে পাচ্ছেন?
হ্যাঁ, স্ক্রিন শো হচ্ছে, আপনি হ্যাঁ 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 দেখা যাচ্ছে।
দেখা যাচ্ছে?
হ্যাঁ হ্যাঁ হ্যাঁ।
Okay. Okay, now I'm going to discuss about the novel synthetic routes and the importance of various amide in organic chemistry. Okay, we know, I think, that amide is very much important in organic chemistry because many natural products, drugs are contain this amide moiety. So I will little bit discuss about this amide moiety. So the general overview of amides. What are the amides? So the amides are derivative from carboxylic acid. So a carboxylic acid is the C double bond O and OH group is present there. So when OH group is replaced by the NH2 group, it will be the amide. So the amide functionality contain CONH2 group for the primary amide. So the acetamide is a primary amide and is very well known and the very simple. Common amides is the acetamides and the benzamides. Is very common and used in many cases. And there are some physical properties of this amide. These low molecular weight amides are soluble in water, but other amides are not soluble in water. And these amides compounds are very stable. So there are very many types of amide compound. This is a primary amide, secondary amide, and tertiary amide. Here from the image you can see this primary amide contains UNH2 group, and the secondary amide, when the NH is substituted by any other group, it called secondary amide, and when N is substituted by two other group, then it make say that it is tertiary amide. So for the secondary and tertiary amide, there are another types of amide. This is called cyclic amide or lactam. It depends, and the ring size may be vary from 5 member, 6 member, 7 member ring. So these are the cyclic amide or the lactam. So here are some synthetic importance of the amide moiety, because I think this segment of Taxol and this penicillin and this paracetamol, you know, I think these things are so many. These are the drugs. Taxol is used for cancer treatment, and we use this paracetamol also as the painkiller. So these things, and piperine is the natural products. So all these moiety contains, you can see this amide moiety, all these compound contain amide moiety. So it is very important that many drugs and natural products and bioactive compounds that contain amide moiety. So these are the important to the researcher to develop more about this amide. So we are interested to work with this amide. So accordingly, I also worked during my PhD with this amide. So I try to say some synthetic routes for the amide that are developed by in our laboratory during my PhD. So in classical method for the amide synthesis is when a carboxylic acid and a amine moiety was coupled in presence of some coupling reagent, then we can synthesize this amide moiety. But it is the classical approach. Previously, from long time it was used, but the disadvantage of this method is when we use a coupling reagent, we should use a lots of amount, means stoichiometric amount. So as the side product will develop, that is not helpful to our environment, and it is also economically not good. So we tried to find some synthetic route for the synthesis of amide that we can prepare it very easily, and economically it will be good, and the environmentally also friendly, also the methods. So we tried to develop some method and new methods, and we'll discuss here this method one by one. So here I will discuss 5 methods for the synthesis of amide, and these 5 methods I was developed during my PhD in IIT Guwahati. So I'll discuss about the 5 methods and what are the advantage of our method that was developed. And this we have developed this method, and it was published in a very good international journal already. So I will try to discuss about this amide method. So it is the first method where I prepared the amides from aldehyde, and it was done by amine transfer method. So here it is the reported method from where aldehyde to amide was prepared. It was many methods are reported, but in those cases they use some metallic reagent. Metallic reagent means some catalyst like palladium, platinum, gold, silver, etc., ruthenium. These metal catalysts are very expensive, and this reaction was done in presence of air or any oxidizing agent. Here you can see TBHP, hydrogen peroxide, MnO2 is the oxidizing agent for the synthesis of amide directly from the aldehyde. And there are some other methods where metal catalyst did not use. So they use some organocatalyst and photocatalyst. And this photocatalyst and photocatalyst also is expensive, but organocatalyst you can prepare in the lab, but it is also difficult to preparation of this organocatalyst. So this reaction was done also in presence of strong oxidizing agent. So here, these are the summarized method that was known. So we tried to develop another method which will be more easier than this method. So we tried to develop a method for the synthesis of amide directly from the aldehyde. So accordingly, we did a reaction like this. Here we use aldehyde and we use a 9-fluoroamine as a compound, and in presence of air or oxygen we prepare this amide, and you can see this 9-fluoroamine, this amine called 9-fluoroamine. So it was formed 9-fluoronone as the byproduct. So this byproduct is not, we can separate once again. When we purify this amide, we can separate also this 9-fluoronone, this ketone. So again, we can use for the synthesis of amine, then this amine again we reuse. So this is the, here we did not use any metal catalyst or any other strong oxidizing agent. Only in presence of air or oxygen, it formed the amide. So it will be more economically favorable and also environment friendly. So we tried to develop this method for the preparation of amide directly from the aldehyde. So when we got some result, when we did the reaction, we got some result, but it was not good. Yield was very less, compound was forming. So we started to optimize the condition of the reaction. So we started to optimize the condition. We did many reactions to find the best condition where the amide will be the main product and yield will be very good. So here you can see in this table, we did lots of reaction. So we have seen here only 12 reaction. Okay, then from the number 8, you can see this is our condition that we got the highest yield. So accordingly, we choose also this amine also for the preparation of this amide. So then we did the reaction. So from here, then we prepare many various types of substrate. Here you can see this various types of aldehyde are used. Here this aromatic aldehyde and this aldehyde like cinnamaldehyde also used, and many different substituted aldehyde. Here electron withdrawing substituted as well as electron donating substituted aldehyde was working to the preparation of the amide. So the main advantage of the method is there, we prepared this amide by using oxygen only. No other metal catalyst was used for the preparation of this one, and this 9-fluoronone was formed. We recyclable this is. So here the yield is also good. Here in one also natural amide we have prepared by single stem method, because this natural amide is not easier to prepare in a single stem method. And then we prepared also many secondary amide also like this. When we use a substituted amine, then we prepare this benzamide derivative with the secondary amine. These are the methods. Some secondary amide also here prepared, and we did some control reaction to prove the mechanism that reaction is going in which pathway. We have to give a proposal that reaction is going like this, because we can't give any things that reaction is going via like this. We have to prove it. So we tried to prove this mechanism that reaction is going via this pathway. So accordingly, we did some reaction. So first we thought that aldehyde may be oxidized in presence of oxygen, then it formed to the acid, then acid reacted with the amine to form the benzamide, but we did the reaction with the acid, did not give any product. So again we did a reaction where the aldehyde and amine forming a C base imine, then it reacted with the triethylamine and oxygen to form the benzamide. So from the mechanism you can understand the reaction, how it's going the reaction. See, from the first the amine reacted with the aldehyde and water molecule was released to form ion intermediate. This iminium ion intermediate, when used triethylamine, so see here we use the secondary amine. If we use primary amine, it will form a imine. If we use secondary amine, it will form a iminium ion. Okay, then this imine or iminium ion reacted with the triethylamine to form a azomethane anion where the minus charge will form. Then this anion, it may convert it to another isomer. You can see the two isomer is possible. So these two isomer, one of this isomer, and we don't know also which isomer reacted with the oxygen. So we guess the second one is reacted with the oxygen to form a hydroperoxide complex. So hydroperoxide complex was formed with the oxygen. Then when it was rearranged to form the two pathway, it may go via pathway A or via pathway B. So it means if it go via pathway B, A, then a cyclic peroxide will form, and when it will react with the triethylamine, it will rearrange to form the amide and the 9-proenone, which is the, again we can prepare this amine from this 9-proenone. And the reaction is going via pathway B, it will form a amide amide ion. Then after hydrolysis, it will form a the 9-proenone amide and 9-proenone. So from here, that reaction is going via pathway A or via pathway B. We have to confirm it. So we did some another reaction to confirm this. So we did the reaction with in presence of oxygen also. Oxygen labeled oxygen. I think you know the isomer of the oxygen. One that is the nature, and in the nature that oxygen is available. That 16O2. That is available in nature. So if we and this is an isotope, and it is very rare in the it is very rare and very expensive also. We can buy it from the company, and it is this isomer is very much, this isotope is very expensive, 18O2. So we did the reaction in presence of this 18O2. So when we have seen that amide oxygen is labeled with 18, and how we confirmed this was labeled with 18. So we take the mass HRMS. I don't know you know or not that HRMS. From the after the compound, we measure the HRMS. What is the mass of this compound? So if we measure the mass, we can understand that if oxygen, normal oxygen is there, then it will be 16O2. And if 18O2 is there, then mass will be increased by 2 digit. So we have noticed this from the mass, that our mass is increased 2 digit. So from there we confirmed that amide oxygen is labeled with 18, and we got also side product, this 9-proenone, that was also labeled with 18. So from there we conclude that reaction is going via pathway A, not via pathway B. And another experiment we did that with H2O18, that amide oxygen is coming from water or from the oxygen, because from in the environment there is also moisture also that contain H2O. So we thought maybe that amide oxygen, that oxygen is coming from the moisture or water, not from the oxygen. So to confirm this one, we did also experiment with H2O18, but we have seen that amide oxygen was non-labeled with 18. So from there we confirm that amide oxygen is coming from 18, oxygen, environment oxygen, not from the water. And we calculated also the percentage of the isotopic purity, because this is how much compound was labeled with 18. That was also calculated by this graph. So the conclusion of this method was there, is there. So here for the aldehyde to amide synthesis, we did not use any metal or any hazardous oxidant, and the scope is excellent, and chemoselectivity also formed. Chemoselectivity means one compound will form when is the 2 position to form the compound. Then one will specifically react 1%, one portion of the compound. This is called chemoselectivity. Means there are 2 possibilities to form the product, 2 position to react, but specifically react in 1 position. This is called chemoselectivity. So here, if we use a ester derivative of aldehyde, so in para position of the aldehyde, it will be ester. So if we react with the amine, so we have seen that preferably react with the aldehyde. Ester did not react with the amine. So this is called chemoselectivity. So we observed in our reaction that type of chemoselectivity. And here oxygen was used as the green oxidant and source of amide oxygen. This is the major advantage of our method, that we use the oxygen as the source of amide oxygen. And the facile access of 18 amides. This 18 amide, I told you, this 18 amide is very much expensive. As the oxygen 18 is expensive, so from there we have prepared 18 O amides that is labeled with 18 amide. So it will be useful for many types of reaction or many industry or anywhere. It will be useful, this method. And the second method, here in previously method, we have shown the synthesis of amide from the aldehyde. So now in this method, we will show some method that will prepare amide from the amine. And the title of this method is the metal-free thermal activation of molecular oxygen enabled direct alpha stage to oxygenation of free amines. So you know the amine. So amine, where the alpha position of this NH2, there we will activate, and there will put the oxygen. So it will be the amide. So I think you know that alpha position. Alpha position is the when is the functional group is there, just side of that carbon, it's called alpha. And after that, second position is beta, third position is gamma, like this. So we will activate the alpha position of amine to form the amide. So we'll discuss the method now. So there are some methods prepared in the literature available. I have seen in the preparation of this type of amide. Here, see that they have used a amine, and then they use some activator like metal catalyst, metal reagent, and some oxidizing agent. So they activated this alpha position, and there CO was there. You can see this was CO is there, so it will form a amide. So just activate the alpha position with the oxygen or some oxidizing agent in presence of metal catalyst or oxidizing agent. So here another method also, they used also organ catalyst or photocatalyst and some strong oxidizing agent. So they prepared this type of amide or lactam. So we wanted to also develop a method for this transformation, but we wanted to use it without using anything, any reagent like metal catalyst or organ catalyst we will not use. We want to functionalize this alpha position of this amine to form the amide. So accordingly, we did in the reaction. So this is the previous reaction. You can see the previous reaction, we use this aldehyde and the amine. Amine, we choose the 9-phenamine. So this aldehyde and amine and reacted to form this type of amide. So here we will show, and this amide was formed via this intermediate. In the mechanism part, I have shown this type of intermediate. Azomethane anion was formed. And this previous work, which was published in Organolether 2016. So this one, we thought it was, if we use the different one, if we use a ketone and a amine, then it may form the similar types of intermediate, and then it can be form a secondary amide or primary amide from the amine, directly from the amine. So the opportunity of this method will be direct alpha oxidation of amine, and no metal, no oxidant, no additive will be used. Then like this, we started this method like this. We used this amine, benzyl amine we used. Then we used a 9-phenone or 9-phenamine we used. So we tried the condition of Beck's, and in presence of air, we have seen the alpha position of the amide was amine was activated, and it was form a amide compound. So from here you can see this, we can synthesize amide directly from the amine. And here we did not use any other catalyst, only we use 9-phenone and this is 9-prenone is again we can recyclize this 9-prenone. When it was formed, we can again use for the next step reaction. So we did this reaction, and previously we got a little bit less yield, so started to optimize the condition, and we have seen the best condition where 70% yield was formed, and it was the number 5 when we use this 9-prenone imine. When X is NH, you can see this X is NH. Then this use oxygen and reflux in toluene, so it was formed 70% yield. So then we prepared different types of amide directly from the amine. So this is a very good method that we can prepare many types of amide with good to moderate yield. You can see 70%, 62%, and various types of amine was used. This heterocyclic compound, so heterocyclic amine also reacted to form this amide, and this aliphatic amine, long chain aliphatic amine, like their chain number you can see 15. When the chain number is 16, then we can also use this amine to form the amide. So here basically the alpha position was activated with the oxygen, without metal and without any oxidizing agent. So it is the first time that we did this reaction without any metal catalyst or any oxidizing agent, only presence of oxygen and reflux. With the amine, we did this amide synthesis. So it will be very useful in the industry also, because they wanted to do this reaction without any catalyst, and that will be environment friendly, and also the cost also be less. So here we also prepared the secondary amine, and we also talked about the lactam. These are the lactam we have synthesized. So this above are the secondary amide we have prepared, and these are the lactam moiety we have prepared. Lactams are prepared with very good yield, like 82%, 76%, 74%. So in this method we can prepare also lactam also, as well as secondary, primary, different types of amide we can prepare. So we have prepared our method we used to preparation of medicinal drugs and their analogs. So this glibenclamide is a very well-known drug in medicinal chemistry. We use this glibenclamide on treatment of various types of disease. And these are the alibendal, and these are the bezafiprates, and these are the buclosamide, an antifungal agent. So these are the well-known drugs, but by using our method, we have developed this synthesis, we have developed a synthetic route for the preparation of this drug, which is more economical and use less number of steps. So it will be much more useful in the industry that to use our method, because it will take less time and economically less budget, and also the environment also be friendly, because we don't use any other toxic reagent or any other hazardous reagent. So we are using any very simple reagents, and we can prepare these drugs in a less number of steps. So it will be more useful in the industry for the preparation of this type of drugs, and these are very useful also, these drugs are. And these are we did some control reaction to prove the mechanism, because how the reaction is going on. To understand, we did some several reaction to understand the mechanism. Then we concluded a reaction mechanism. And here also the same, we did also a leveling experiment with H2O18. So from here also we can see this H2O18, when we did the reaction with H2O18, no 18 is incorporated in the amide. So from there concluded that H2O18, so amide oxygen is not coming from H2O, not from the water, it is coming from the oxygen, like the previous method. So we given here some mechanism like the previous method. Here you can see the similarity of the mechanism. Previously we use here different opposite things. Here just we use the opposite one. Here amine part and the ketone we used, then form an iminium ion, like the previous one, then it react with the oxygen and this the amide. And the conclusion is a new and more greener and simple approach for the amidation was prepared without metal, and any hazardous oxidant was not used, and simple mild reaction condition was used, and applicable for a wide range of amines. Various types of amine reacts, and alpha amidation of amines without metallic reagent. That is very much challenging, that we can activate the alpha position of amine without metal. It is very much challenging, and we did this. So this I think it is a nice method for the preparation of the amide directly from the amine, and it was also published in JOC in 2018, an international journal by American Chemical Society. So these two methods, so we just give a summary of these two methods that we have described. In the first method, we have prepared amide from the aldehyde, and the second method, we prepared amide from the amine. So basically, this is the mechanism is basically similar, that similar types of azomethane anion was formed and then react with the oxygen to form the amide. But these two are different methods. Mechanism a little bit same, but method is different. One is from aldehyde to amide, another is from amine to amide. Now we'll go to the third method for the preparation of cinnamomide and piperamides. For the synthesis of cinnamomide and piperamide. So I'll little bit discuss about the cinnamomide and piperamide. So what is the cinnamomide? So these are the called cinnamomide. When some alpha beta position, it is a double bond in alpha beta position. See the alpha position and beta position, the amide functionality you can see from their amide functional group, and the side first position is the alpha, second position is the beta. So a double bond is there in the alpha beta position. So it is called the cinnamomide. And piperamides. The piperamides is a natural product, and it was extracted from the pipers, and it is a natural product. So from there it named as the piperamides or cinnamomaids. It is very much important, this cinnamomide of piperamides. It is important from the agricultural point of view. Like this cinnamomide is used as the piperamides used the anti-CTCL, insecticidal, fungicidial, mosquito larvicidal, and antibacterial properties also have. So it is very much important from the agricultural point of view, as well as it is important from the pharmaceutical point of view, because these piperamides used as anti-cancer agent, anti-platelet agent, anti-inflammatory agent, anti-parasitic agent, and others. It has some other therapeutic properties. So we wanted to show, as it is very much important, so we also interested to synthesize this type of cinnamomide or piperamides. So accordingly, we choose some different method for the preparation of this one. So we will just discuss about the previous method that was known for the synthesis of cinnamomide. Here it is the cinnamic acid. When the cinnamic acid reacted with the amine, it will form the cinnamomide, and this reaction will present. Will work in presence of coupling reagent like SOCl2 and carbonyl chloride, other NHOBT, EDC, BOP, etc. as the coupling reagent. So when cinnamic acid react with the amine in presence of coupling reagent, it will form the cinnamomide. It is the first method for the preparation of cinnamomide from the cinnamic acid. In the second method, cinnamomide was prepared from the cinnamaldehyde. When we use a cinnamaldehyde and it react with the amine to form, and it reaction will do in the presence of a NHC. It is a carbene catalyst. NHC is a carbene catalyst. Carbene, I think you know the carbene compound. So this carbene catalyst also used for the preparation of the amide from the aldehyde, cinnamaldehyde, and amine. And another method is there when we use benzaldehyde. Benzaldehyde when we use, and some reagent we can use like this reagent. We have mentioned here reagent. This reagent when we used in presence of base, it will form the cinnaamide. So from here, basically, we have seen there are three methods reported: one from the cinnamic acid, one from the cinnamaldehyde, and one from the aldehyde, or normal aldehyde to cinnamide. So we are interested to do the reaction from the aldehyde, because if we start the reaction from the aldehyde, then it will be single step to form the cinnamide. We wanted to do it also in a single step reaction. Here they have used this reaction, coupling reagent and any other oxidant and any reagents they used in stoichiometric amount. It will produce a lots of byproducts that we will not use. So this atom economy of this reaction will be less. So we wanted to avoid this type of reagents, these coupling reagents and these other reagents to prepare of the cinnamide. So we wanted to also prepare this aldehyde, because the benzaldehyde is more easily available than a cinnamaldehyde or cinnamic acid. So we wanted to use the benzaldehyde for the preparation of this cinnamide. So the limitation of the previous method are the coupling reagents, metal catalyst and oxidant were used, stoichiometric amount of waste released, and no single step method reported directly from the benzaldehyde to cinnamide method, cinnamide preparation. Here in the third method, we have shown the benzaldehyde was used and the reagents were used in base and it will form the cinnamide. But it is not in a single step, it is a multi-step synthetic procedure. It is I have mentioned in a single step, but during the reaction it needs a multi-step reaction. 3-4 steps reaction needed to form the cinnamide products, and so the obviously the overall yield is very less. We got very less types, less amount of compound. So these are the limitation of the previous methods. So we wanted to develop a method for the cinnamide synthesis, as it is very much important. So we wanted to develop a method from the aldehyde, benzaldehyde. So this is our method we have developed. We thought, and our focus was to develop a method for the synthesis of amide. So we thought different types of condition and reaction. Then we were successful to prepare this cinnamide. We did lots of reaction. After this only we successful to form this cinnamide. So here we used a benzaldehyde, parachlorobenzaldehyde, and a benzylamine and a Meldrum's acid. This acid is called Meldrum's acid. And so when we use the Meldrum's acid, we did these three in a reaction vessel. We have seen, we have applied our conditions. We have seen the cinnamide was formed. So then we studied the other condition also, different types of condition, that where we get this was the major product. So we have did the many types of optimization. So we concluded a reaction while the yield was formed is 68%, and it is the entry number 6, where toluene was used. We did the reaction in a closed tube. In a closed tube, just put the toluene and the three reagents, these three reactants like the benzaldehyde, benzylamine and Meldrum's acid were put in the closed tube, and it sealed and just heated at 110 degrees centigrade in toluene, and after 8 hours we have seen that product was formed, and we just purified the compound to form characterize by NMR and mass. We have seen this our compound. So from there we concluded that this is our product, and it is 68% yield. Then we prepared different types of, started to prepare different types of amide. This is the scope in synthesis of cinnamide. Different types of cinnamide we can prepare. So see here, we have prepared different types of cinnamide. Here in the first one was prepared in 1.2 gram scale. It is large scale we have prepared in our laboratory. So it is generally in the research laboratory we use in only milligram scale, like 50 milligram, 100 milligram, 200 milligram. We use to test the compound with this type of much of compound. But the industry, they are used in kg, 5 kg, 6 kg, they 100 kg something. Sometimes they used to do the reaction. So they do the big scale. So here we test a reaction with 1.2 gram scale. So we have seen it was functioning very good. So we thought that it can work in industry also very good. That when they were used in large scale reaction, they will also be successful. It was sure. And here we prepared different types of cinnamalide. We vary both the amine and the aldehyde. Different types of substituted aldehyde or different types of substituted amide was used. So we have prepared very many different types of cinnamalide derivatives. And you can see one is derivative also, it is biologically active. IC50 I have written here, it is active against MCF7. It is a bacteria, so it works against bacteria, so it can prevent the bacterial infection. And it is IC50, it is the activity rate, how much it is active. So we have seen it is a very good compound and it has some biological properties. So we have synthesized this compound also by using our method. And this is the natural products. All are the piper amides. These are the available in nature. It was extracted in various types of plant and piper, various types of piper species. So these are the natural amides, and it is a natural product. So it was extracted from the nature, but we can also synthesize it from in the laboratory also. It is possible to laboratory synthesis, and it is very easy. So natural source is limited, but if we try, we can synthesize this in the laboratory also, these natural products. So it is very much useful, and it has lots of application of these natural amides. So here basically we prepared this amide by a single step and using a very easy available method. Here no byproduct was formed. Byproduct is formed only acetone and carbon dioxide, and both are volatile. So here the byproduct separation is also very easy, and no other product was formed. And this is a single step method. There is no method in literature present that I have shown that from the benzaldehyde, amine and mildenous acid are used, and a single step no method was reported in the literature to form this cinnamalide. So we have prepared this one. So we think this is a very useful method, and we did some control experiment that I did not discuss here in elaborate. So there are actually we did lots of reaction. So all the reaction is not possible to discuss here. So after doing that much of reaction, we concluded a decision. We come to a decision that reaction is going via this pathway. So we just 3 reactions we have shown here to discuss, and this is the mechanism for the reaction that was concluded from our many controlled reaction, that in which direction reaction is forming, how it is going on. So we have decided based upon the reaction we performed. So here you can see this amine first reacted with the mildenous acid, and when it reacts, one molecule of acetone was released, and it will form a acid amide derivative, and it react via pathway B or pathway A to form and react with the aldehyde, and it will form this type of intermediate, and which after carbon dioxide release it may form the cinnamalide. We proposed this mechanism based on the control reaction we did in the laboratory. And the conclusion from this method is there: new multi-component single-step reaction for the synthesis of cinnamalide and piperamides was developed. Easy and mild reaction conditions are used. Natural products synthesized in one step, applicable for gram scale synthesis, and byproducts are very easily separated. So one thing I want to say, that this is we think that this is a very good method for the industry, because one step we can prepare this natural product and the cinnamalide. And this paper was published in Green Chemistry Journal, and which is published by Royal Society of Chemistry, and the impact factor is 9.4, very good paper. So they have published our work in their journal. And also another thing, we filed a patent, Indian patent for this method, because if industry also can use this method, and it was successfully filed in a patent. for the synthesis of this by based upon this method. So it is a very good synthetic method for the preparation of piperiamides or cinnamamides. And this next method, we will show the acetylation. Like amine, if we use amine, then it will form a acetyl compound, acetylation. So generally acetamide will synthetic route develop to formation of acetylation, acetylated product like this. Here the previously conventional method are there for the preparation of acetylating agent. Here they used acetic anhydride, acetyl chloride, acetic acid, etc. They are used stoichiometric amount of reagent or catalyst. Then they use this type of acetylated product. If X is N, then it will be formed the acetamide. And in our method, previous method, you can see I have shown in mechanism when this Mildam's acid reacted with the amine, it will form a acid amide derivative like this intermediate. And when we use a benzaldehyde, we have seen this type of cinnamamide that was shown in previous method. So from this method, we got the idea for the acetylation. So we thought if we can use this method for the preparation of this acid, then if we start to heat, we will not use any aldehyde in the next step. We just started to heat, then it may form that this carbon dioxide may release and decarboxylation. This is generally decarboxylation. After decarboxylation, we can prepare this type of acetylated product. You can see this acetylated product. So we thought this method may be also useful, that all the conventional method used for the acetylation is used acetic anhydride, acetyl chloride, acetic acid, and they are used some stoichiometric coupling reagent or something. But here in our method, we can do this reaction by using only heating in following. No other reagent or any catalyst need. And another thing, this acetic anhydride, it is now banned because it is some some people used for this synthesis of many heroin, cocaine like this. They use acetic anhydride used for the synthesis of that one. So it was government, our Indian government, basically it was banned. So we find some synthetic procedure, different synthetic procedure for the preparation of this acetylation. So we developed another method for the preparation of this acetylated product by Mildam's acid. And this Mildam's acid is very good for the synthesis of this one. So first time we have developed this method. Previously nobody was used this Mildam's acid as the acetylating agent. So we have shown here first approach that Mildam's acid can be used as the acetylating agent without using any coupling reagent or any catalyst. So basically here the primary, secondary and cyclic amines reacted just with the Mildam's acid and it was formed the acetylated product. So here you can say various types of acetamide derivative was formed. Many acetamide derivative was prepared with very good yield. Here when we did the reaction, after reaction we have seen the solid product was formed and we just filtered out the solid liquid part and we collect the filtered one and just dry it and just check the NMR, proton NMR and 13th NMR also and mass also, and we confirm the product and analysis like this. So product formed with excellent yield. You can see that conversion almost 100%. And the last one, it is a derivative of ciprofloxacin. Ciprofloxacin is a drug which is used in the treatment of eye. Ciprofloxacin. So we use the ciprofloxacin derivative, and you can see the amine part was protected by the acid as the acetamide derivative. Acetylation was done. So different types of amine was acetylated by using Mildam's acid. So we developed this method also for the preparation of the acetamide derivative. It is a kind of amide. So here you can see this primary amine of the aniline. Aniline is an aromatic primary amine. Here you can see this aniline also reacted smoothly to form the desired product with excellent yield. This is the aromatic amine. These are all the aromatic amine also reacted. So previously we have shown these are all the aliphatic amine. Here we have shown all the aromatic amine. So aromatic amine also reacted Here a different thing, this alcohol also reacted. This is not the amide, this is the ester, but I have shown here because this our method is also applicable for the synthesis of ester and also thiol also. You can see the fifth number of example. This is also thiol. So the reaction is also applicable for the alcohol and thiol to preparation of thioester and ester. This is not the amide, but also included here. And here some secondary derivative also prepared. And this is the control reaction. We selected control reaction we have given for the prove the mechanism. Here see like the previous reaction. Here also it formed the it react with the Meldam's acid to form a acid amide derivative. Then just after heating in the presence of base, we don't use any external base because this amine itself used as the base. So when after decarboxylation, it was formed a acetyl derivative. And conclusion of this method is there. Meldam's acid used as the acylating agent and acetylating agent. Meldam's acid is very cheap and handling is easier. Easy and mild reaction condition were used. Acetone and carbon dioxide as the only byproducts. No catalyst were used for the acetylation of amine. No column chromatography for acetylation of amine was required. Applicable for gram scale synthesis. So this is a very nice method for the preparation of the acylated product, because there are many methods reported for this synthesis. So it is a competition like this, that which method will be better and which is the best. So I think this is a very good method. I don't know it is the best or better, but it is a very good method, I believe, that for the preparation of the amide, and it is well substituted for the acetic anhydride, which is banned, that I have told. So we can use a different types of method for the use of for the preparation of this acetamide derivative. And this is the last method that I have prepared recently. Just last year I did this reaction, and this year also January also I tried some reaction on this, and it is not published. It is under communication. So it is here we have prepared. It is a cyclic amide that I have discussed, cyclic amide and lactam. So it is multi-step synthesis, but it was done in a single pot. In a single pot, we just add various types of reactant, and it was done in a it was formed the product, but inside that it was a multi-step procedure. Procedure is multi-step, but we did in a single pot. It is called. Just we mixed all together and we got the product. So inside that it was a multi-step, but we did it in a single pot. So these are the N-lactam, and here are some methods I have shown here. This is the preparation of this method previously. N-lactam like this. It is a two-step procedure. They used some also mercury. Also they used pressure. They used by pressure. And these are developed in 1997, and these are another method that was developed in the year 1993 for the preparation of the N-lactam moiety. This is all the lactam, but N-lactam. Why it is N-lactam? Because you can see the double bond in the position of the middle. So it is called N-lactam. Lactam, but N-lactam. Here the amide, the N-lactam were prepared by ruthenium catalyst, and here also they used aluminum bromide, sodium brohydride, etc. And they did the reaction in a very minus temperature, means minus 5 degree to 0 degree centigrade temperature. And these are also some methods reported in the literature. I'm not discussing about this method with very elaboration. But see this method that was reported. There of maximum cases they used multi-step procedure, they used high temperature, etc. So here these are also two methods reported in the literature. So this method, you can see they have used more than 2 steps, 2, 3, 4 steps. They used high pressure, high temperature, sometime use metal catalyst, everything. So we wanted to develop a method for the preparation of this N-lactam. So because we have seen in the literature, this N-lactam is very important compound in the for the many types of drugs and natural products while prepared via this N-lactam derivatives. It was used as the intermediate, so we interested to prepare the N-lactam derivative. So from there we did the reaction. When I prepared the cinnamonide, we used all the same compound, same substrate we used, but here see we just changed the equivalency. 3 equivalent of benzaldehyde and 1 equivalent of benzylamine and 2 equivalent of melanoxacin. When they react together, we have seen this type of product, and this product is very much interesting. It is a spiro type compound. So spiro compound always is very much interesting because it has some biological properties. We have seen that spiro compound is very much biologically active, and as well as it has also lactam moiety. So lactam plus spiro. So obviously this compound will be very much interesting, and it will have some biological property which can be active. So we did some experiment optimized condition to increase the yield. So we got highest yield 68%. When the reaction was done in a closed tube, after 24 hours, we got the 68% yield. And this compound was confirmed by the crystal structure. From the NMR, we did not understand this compound. From proton and 13C, and from the mass, we could not able to confirm this compound because its structure, you can see, it's a versatile structure. We did not think that it may form. So we have the structure was confirmed by the crystal X-ray crystallography, and the stereochemistry. You can see the stereochemistry of the compound. It was also confirmed from the crystal structure. And you know the diastereoisomer and enantiomer, I think. So it is the 3 chiral center. From here you can see. But we got selectively 1 compound. So theoretically, it should form 3 to the power n. Means 2 to the power n. Means 8. 8 diastereoisomer is possible. But we got only 1 isomer selectively. So it is a very much selective reaction. That's why I told stereoselective reaction, because only 1 diastereoisomer was formed selectively. Although theoretically it is possible 8 diastereoisomer. And we use different types of aldehyde here. See, the different types of aldehyde were used to form the and react with the benzylamine and melanox acid and reflux condition. And in toluene, it was formed the stereoselective compound. And here the yield is also good to moderate. And here the crystal structure, the compound was confirmed from this crystal structure. When we put the crystal in the X-ray, that instrument is there, they will show the structure. So this is the structure, and it was confirmed from there 100% that compound is this, and the stereochemistry of the compound also from the relative stereochemistry also confirmed from this crystal structure. Without crystal structure, it was almost impossible to confirm the structure and stereochemistry. It was very much means the structure is versatile and is very complicated. That's why I'm thankful that we got the crystal. And here we varied the amine part. Here we use benzaldehyde and different types of amine we have taken and react with the melanox acid, and it was formed this type of spirocyclic N-lactam compound. So we have prepared this type of N-lactam compound with good yield, and different types of substituted amine was reacted smoothly to form the desired N-lactam compound with good yield. And see the cyclization. When we did the reaction like this, and we just add the triflic acid. When we use triflic acid, it was cyclized and formed the ketone type compound. So it is a very good, interesting product, and it was also confirmed from the crystal structure. So you can see in the mechanism part, I have shown how it was formed. And when the reaction was done, just I add the triplylic acid. And triplylic acid, when was used, it was formed the and triplylic acid, TFOH, it is the full form is trifluoromethane sulfonic acid. So it was a very good Lewis acid. So when it was given in the reaction mixture, we have seen the cyclized product. And the cyclized product was formed with very good yield. In the bracket, we have written that when the spirocyclic compound in the previous, this one when we got, if we add inside it the triplylic acid, it was cyclized automatically. So from here, after isolation of this, when we did the reaction, yield is very good. But when we did a single pot, yield is a little bit less. And also when we use DDQ after this, see, when we use DDQ, we have seen this is aromatized. The compound is aromatized with DDQ. So we have to prepare two substrate with this aromatized compound. Then see, we used MCPBA. When the reaction was done, we used a MCPBA, so it was form a epoxide compound. It is looking very good, this compound. So we have prepared many types of compound, and it is also confirmed from the crystal structure, this type of MCPBA, and it was form a hydroxy, as well as hydroxy and as well as this epoxide product. So this is the mechanism very long and very complicated mechanism. So we tried to prove this mechanism. We did many types of reaction, different types of reaction. So from there we concluded this type of mechanism. Like this, first amine reacted with the Meldam's acid to form a acid, and then acetone, and this when it react, this acetone when react with the amine, it will form a amine compound. This amine compound when reacted with the benzaldehyde or any aromatic aldehyde, it will form this type of iminium ion. Then after rearrangement, it is formed this type of amine. Then when benzaldehyde react with the Meldam's acid to form this type of compound also, then it react with the then these two react combine together to form a spiro compound. See, again this spiro compound is converted to like this. Then we prepared this type of compound, and this was the final compound after decarboxylation. So this carboxylic derivative was identified by mass. Then when we use triplylic acid, we have seen that one aromatic compound is combined with the this Meldam's acid, and after decarboxylation, it was formed an acetone release. It was formed the cyclic compound, and after when I use DDQ, it was formed the aromatized compound. And when you use MCPBA like this, it will form a epoxide. Then epoxide will open. Again, it will form this type of iminium intermediate, and then amine, then followed by MCPBA. Again, one equivalent of MCPBA was used, so it will form another epoxide. Then after rearrangement of this compound, you can see it was formed this type of epoxide as well as hydroxy product. So this is our final compound. So this is the mechanism. So from there, this is the conclusion of this method is there. Single port multi-step process for the synthesis of N-lactam, and products are highly substituted and diastereoselective. That I told, that is very much diastereoselective and highly substituted. Although 3-chiral center is present, although it formed one diastereomer selectively. One diastereomer was formed selectively, although there are 3 stereocenter in the spirocyclic N-lactam product. No catalyst or additive were used. Prepared from easily available starting materials. Cyclic ketone and 9-fluorine derivative also prepared. That we have discussed later. And this is my overview of my work. In the first work, you can see the aldehyde to amide was prepared by amine transfer method. It was published in Organic Letter. It is also a journal by American Chemical Society, as a very good journal, reputed journal. It is impact factor of around 6.5, and that aldehyde to amide synthesis was done by amine transfer. It was published there, and this was the second one where amine to amide we have prepared. It was published in Journal of Organic Chemistry. It is also the journal by American Chemical Society, and this one I did not discuss. It's in my thesis work. This is also published in Organic Biomolecular Chemistry. It was a journal by Royal Society of Chemistry. I did not discuss here about this work. So when cinnamonide and piperamide was prepared, I have discussed in the one method. It was published in Green Chemistry in 2019, and that acetamide I have shown, it was also published in Green Chemistry in 2020, sorry. And this method I have shown in last one, that under preparation, or it was just communicated a few days ago. This is a spirocyclic enlectum, so it is did not published still now, so it is under process, this method. And this is my list of publication. This is all the procedure I have explained, all done by me and helped by some other people in the lab. And it was done by under professor, my supervisor, Professor Jana, and he's my supervisor. And one patent, this was and here also in my postdoc, here also I am working on this amide synthesis, but different types of, this is alene type, alene enamide I am working on it without metal catalyst. So one patent also I have filed that I discussed before for the preparation of the cinnamonide. And this is my acknowledgement part. It is a very, very vital part, because I always thankful to my PhD institute, IIT Guwahati, and my postdoc institute, Strasbourg University in France. And I am also very much thankful my supervisor, Professor Chandan K. Jana. Without his help and guidance, it's never possible to complete my work and my PhD. And I am also thankful my postdoc supervisor, Professor Lawrence Miss. He helped, now he is doing a lot of help, and he is helping me here in this new country. And I also thankful Dr. Mrinal Chattopadhyay, the principal of Kandra RKK College, that under Bardhaman University. So they given me the opportunity to present my thought to this virtual platform. And I also thankful all the organizing member who did this nice things, and they organize good things that online we can present these things. So especially I also thankful Sujit, that he helped me a lot, and he also contact with me for this conference. So I thankful to Sujit and Kandra, and overall I am thankful to Kandra RKK College, Bardhaman University. And I also thankful all the audience for listening my thought and my work. And I also thankful my lab members, previous lab members, also my present lab members, everyone, and my friends. And last, I am always thankful to my parents for their help and support from throughout my life. So this is my thank you for everyone for listening. So this is the last. Hello.
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 Dr. Sadhu.
Yes.
Thank you very much. Thank you very much. This is a very pleasant and nice talk, and your work is very good, excellent. In fact, I was quite impressed when I've seen that you have studied with oxygen level study for mechanistic viewpoint. So I myself have done several amide synthesis when I was in Glaxo. So I used to use TU2 as reagent, where I used to make from acid to amide. So yeah, you might have known about this reagent. So
Yes.
Your work is excellent, and from viewpoint of academic work, you have done that isotope leveling mechanistic study that is very impressible. Have you any idea that you use mostly? I have seen that toluene as solvent, whereas
Following is
many other similar work people reported there, like some aportic polar solvent like DMF and all are working very well, which are not working here
yes,
well.
yeah, actually DMSO, DMF, it work fine. Yeah, DMSO. But we generally try to avoid DMSO because it is separation of the isolation from the DMSO is a little bit difficult than toluene, because in toluene we can just evaporate. But when we DMSO is very polar, and our compound is also very polar. And during workup, DMSO is not removed properly. So when we do column, so it will come with the compound. So it will mix with the compound. It is separation a little bit difficult. So we try to avoid this.
Okay. Yeah, obviously, when toluene is working well, then why to use DMS?
Yes.
But sometimes I also felt that while I have seen that many intermediates are making some conjugate ion pairs kind of thing within
Yes.
within the system, and I thought maybe this kind of solvents are also hampering for the formation of those kind of intermediates.
Yes, maybe that.
Yeah. So that's why DMF is giving low yield, I guess. So anyway, if anybody from the audience is having any questions, please ask Dr. Ghosh.
Yes.
From audience, anybody? I guess nobody has any question. So finally, I thank you, and I hope you in future, if we do any kind of webinar, I hope you will be there again. And
Yes.
I would like to thank all of you, all the audiences, and especially I would like to thank our principal sir and our colleagues and our technical staffs. Without them, it won't be possible to conduct this kind of webinar process. So I would like to thank all of you. So I would like to ask Principal sir, say a few words at the end. Please.
Thank you all very much for coming today. There was a very nice discussion today. Our student and I benefited from this discussion. Actually, epidemic has been going on their last years. It has a profound effect on the life of the nations. Our higher education has not been left out of this hand. College, university is not starting in the traditional way. Everything is happening online. Studies, examination are all happening online mode. Webinars, seminars, workshops are happening online through the modern technology. I compliment this chemistry department, especially Dr. Krishna Gopal Thakur and Sujit Ghosh for organizing a beautiful international webinar on such a temporary and a contemporary and a highly relevant issue. Congratulations to all who participate in the international webinar as speaker, especially Dr. Shantanu Ghosh and guest. We have learned a lot from this discussion and we have prospered. Thank you to all teachers, non-teaching staffs, GB president and members, students and technicians, especially Sumit Kaur, Indranil Bhattacharya, Shiv Shankar Pandit, Sahabaj Ahmed Mandal, Shafiqul Alam, Jagannath Nath, who made this webinar a success. I am concluding my speech by congratulating everyone. I wish everyone good health during this critical epidemic situation. My dedication to everyone is to all follow the COVID-19's rules, save yourself, and save others. Thank you. আমি ডক্টর শান্তনু ঘোষকে শুভেচ্ছা জানাচ্ছি। আমরা আগেই বলেছি আমরা বিজ্ঞানের ছাত্র নই, কিন্তু বিজ্ঞান মনস্ক। হয়তো আমি কিছু বুঝতে পারিনি, কিছু বুঝতে পেরেছি, কিছু বুঝতে পারিনি। তবে আমার থেকেও যেটা সব থেকে বড় কথা, যে আমার ছাত্রছাত্রীরা উপকৃত হয়েছে, এটুকু নিঃসন্দেহে আমি বলতে পারি। আমরা ডক্টর শান্তনু ঘোষকে শুভেচ্ছা জানাচ্ছি যে তিনি এত বড় একটা কাজ করছেন, বিদেশে গিয়েছেন, পশ্চিমবাংলা তথা ভারতবর্ষের মুখকে তিনি উজ্জ্বল করছেন। যদি কখনো সম্ভবপর হয় আমাদের কলেজেতে যদি তিনি আসেন, তাহলে আমরা নিজেকে ধন্য বলে মনে করব। এটুকু বলে
আমি গেছি আমাদের কলেজে।
হ্যাঁ,
আমি অলরেডি আমাদের কলেজে অনেকবার গেছি।
তাই বুঝি। কিরকম?
আমি যখন বিএসসি তে পড়তাম, কাটোয়া কলেজে পড়তাম আমি।
আচ্ছা।
তো তখন আমি আমার পাস কোর্সের এক্সাম গুলো সেন্টার পড়তো আমাদের কলেজে, কান্দ্রা কলেজে। তখন আমি কান্দ্রা কলেজে যাচ্ছি।
তাই বুঝি। বাহ বাহ বাহ।
আমার বাড়ির কাছাকাছি ওখানেই। তো আমি যখন বোলপুর যেতাম এমএসসি করতাম, তখন আমি কান্দ্রা কলেজে যেতাম বাসে করে।
আচ্ছা আচ্ছা। কোথায় বাড়ি তোমার তাহলে?
আমার বাড়ি হচ্ছে চাকটা, নাম শুনেছেন?
চাকটা। হ্যাঁ হ্যাঁ, আমি তো কান্দ্রা এলাকাতে বহুদিন আছি না, ওই এলাকা সব চিনি আমি। বলো, তুমি বলো কোথায় বাড়ি?
আমার বাড়ি হচ্ছে চাকটা থেকে 3 কিলোমিটার, কিন্তু ওটা মুর্শিদাবাদ ডিস্ট্রিক্ট।
আচ্ছা আচ্ছা।
গ্রাম সাইডে আমার বাড়ি হচ্ছে।
খুব ভালো, খুব ভালো, খুব ভালো, খুব ভালো লাগলো। তুমি আমাদের কলেজ থেকে পরীক্ষা দিয়েছো।
হ্যাঁ, আমি পাস কোর্স এক্সাম গুলো আমাদের কলেজ থেকে দিতাম।
তুমি তো আমাকে দেখেছো তাহলে?
হ্যাঁ, দেখেছি হয়তো আপনাকে।
হ্যাঁ হ্যাঁ হ্যাঁ, সেই আর কি। কত সালে পরীক্ষা দিয়েছিলে?
আমি দিয়েছিলাম 2011।
আচ্ছা
2011।
আচ্ছা আচ্ছা, তখন আমাদের তো সায়েন্স চালু হয়নি।
না, ওই এক্সাম গুলো সেন্টার হতো অনলি।
হ্যাঁ হ্যাঁ হ্যাঁ, ঠিক আছে, খুব ভালো লাগলো তোমাকে। খুব ভালো থেকো তুমি। আবার যখন দেশে ফিরবে আমাদের কলেজে যেন আসবে, এবং আমরা তোমাকে নিয়ে আরেকটা আমরা সেমিনার করবো। ঠিক আছে? খুব সুন্দর হয়েছে। হ্যাঁ বলো। হ্যাঁ, চারটা গ্রাম চাইছে তোমার।
হ্যাঁ স্যার, একটু বলেন কাইন্ডলি।
চারটার কোন গ্রামেতে, মানে মুর্শিদাবাদের কোন গ্রামেতে?
হ্যাঁ,
মুর্শিদাবাদ, আমার গ্রামের নাম হচ্ছে শাহবাজপুর। নাম বললে হয়তো চিনতে পারবেন না।